Okay, so I'm gonna go over this problem that we started in class that I had an issue with, and I realized actually kind of quickly why I had the issue. And it was an issue of interpretation because the problem is asking you for the cost and they're not giving you the cost of the materials. We have to insert another, it's not a variable, but we have to insert a holding place for the cost. So call the cost K for the material of the pieces. So I'm going to go back to the beginning and we're going to go through this problem from beginning to end. So a pencil cup is, let's see, a pencil cup with a capacity of 9 pi inches cubed is to be constructed in the shape of a right circular cylinder. And it's not easy for me to bring the picture down, but so what we have is, let me see here, what we have is a top that is circular. We have straight sides. And we have a bottom that is circular. Okay, that is a really bad circle, but you get the idea. The top is open, the bottom is not. All right, so what I said in class was you have to think about how you're going to deal with the materials here, right? So the bottom material is a circle. Right, and that circle is going to have a radius. We'll call it R. Now, as far as the sides go, if you think about taking this and cutting it right down one side and then opening up, what you're going to have is a big rectangle. All right, and this rectangle would wrap around the circle here to form this cylinder. So I need to label my cylinder. So we already know we're labeling the radius R. We'll label the height H. All right, so if I want to figure out, let's start with the dimensions of the rectangle here. The height is this length here. All right, so the height of my rectangle is the height of the cylinder. This side of the rectangle, well, that's the side that wraps around the circle. So when you wrap something around the circle, you're going around the circumference. And the circumference of a circle is pi times the diameter, or 2 pi times the radius. All right, so the length of this is going to be 2 pi times the radius of the circle. All right, so the area here, the amount of material that we're dealing with is going to be, well, it's the area of a rectangle, which is base times height. So it's going to be 2 pi R times H. The area of the circle is pi times the radius squared. All right, now, if we go back to the problem, all right, if we go back to the original problem, all right, if the material for the base costs 3/8 of the material for the sides. All right, and here's where I just kind of missed a piece in class. We have to define something for the cost of the materials. So the cost of the base is 3/8 the cost of the sides. So I am going to let, I'm going to let K equal the cost of the side. All right, so that's this part. That means that 3/8 K is the cost of the base. Okay, that's what I was missing. All right, so now that we know that, let's see if we can write the equations that we need. So basically the cost equation, right, the cost equation C is going to be the cost for the side, right, which is this piece here. So that is going to be K dollars per square whatever the area is. All right, so that's going to be K times 2 pi r h. And I'm hoping you can't hear my garbage men outside right now with their truck. All right, so that is the cost of the side plus the cost of the base, which is again going to be 3/8 K, because that's the cost of the base, times the material, which is pi r squared. Okay. All right, so that was the first part, getting the correct equation for the cost. Now, notice we've got a factor of pi in here, and we've got a factor of k in here. So before I do anything else, I want to rewrite this. I'm going to factor out k and pi. So k, pi, and then that's going to give me 2rh plus 3/8 r squared. Okay. All right, now we know that the volume of the pencil case has to be 9 pi cubic inches. That's what the problem says. All right, so the volume of a cylinder, right, the volume of a cylinder is the area of the circle times the height. So that is going to be pi r squared times the height. We know that that volume has to be 9 pi cubic inches. So that means this is 9 pi. All right, and I can divide pi out of both sides. So 9 equals r squared h. And that is my constraint. All right, so we want to we want to minimize cost, right? You always want to minimize cost. You never want to maximize cost. Minimize cost subject to the volume. So that is r squared h equals 9. All right, so there's your setup. Okay, that's what I should have had set up originally. Oh, I'm running off a page here. Okay, that's all right. All right, so I want to, just like I did in class, but again, I'm doing this for both classes, so one class didn't see me do this. I need to replace a variable here to get this to be a function of one variable, and h is going to be the choice because I can't solve this uniquely for r. So h is 9 over r squared. And when I plug this in up here, I get that the cost as a function of r is equal to k pi, which I'm going to deal with in a minute, times 2r times h, which is 9 over r squared, plus 3/8 r squared. And for the first class, if you're watching this, this is where, remember I said the problem wasn't going to work out because we didn't have a sum in there to work with, and that was where the sum went. All right, let me move this down so I can start on the next page here. All right, now two things. First of all, this constant here, well, it's a constant. K times pi is a constant. So really, what I have to minimize is what's inside the parentheses here. All right, so when I come down here, my cost function as a function of r, really all I need to worry about is what's inside this parenthesis. All right, because again, if that's minimum, then multiplying it by a constant, that's still the minimum. So let's see, I've got to reduce this down, right? So I'm going to lose one of these with that, and then 2 times 8. Wait, where did my c go? That was weird. C of R is, oh, because I went up and wrote on the next page, is going to be 18 over R plus 3/8 R squared. All right. All right, now I have the function that I can take the derivative of. So I take the derivative, C prime. Oh, I guess I should do one thing first, right? 18R to the negative 1 plus 3/8 R squared. All right, so negative 18R to the negative 2 plus, I'll write this down in 2 steps, 2 times 3/8 R. Okay, I'm hoping that I don't lose that when I hit. No, good, I don't. Okay. All right. All right, so I can reduce this, right? That's going to be a 4. And I can bring that back down. So this is going to be minus 18 over R squared plus 3/4 R. All right, now I need to... I'm trying to decide the best way to deal with this. We've got to get the critical points. You know what? I'm just going to do it this way. Set it equal to 0. We don't need to be as precise here because we have some constraints on this problem already just based on the actual cylinder, right? If R is 0, then we don't have a cylinder. If H is 0, then we don't have a cylinder. So I don't need to worry about that interval constraint here, which means I don't need to worry about the denominator where R is 0 because R is 0 is not part of this. So I'm just going to solve this using cross multiplication. So I'm going to bring this term, well, actually I'll bring this term over. So I've got 3/4 R equals 18 over R squared. If I cross multiply, oh god, 4 times 8 is 32, so that's going to be 72. This is going to be 3R to the third. Excuse me. Okay, dry throat, I'm starting to cough. Not in a bad way, though. Okay, solve for R cubed. So R cubed is going to be 26. Is that right? No. 24. All right, and then R is going to be the cube root of 24, which I don't know what that is. Look at my calculator. 24. 2.88. All right, so 2.88 is what the radius is going to be. Now remember, we were looking for the dimensions. All right, so the height, I got to go back up here for a second. Hang on. The height was 9 over R squared. Okay, so the height is 9 over R squared. So that is going to be 9 over... That is going to be 9 over... I'm just going to work with the 2.88. So, okay, 2.88 squared. So that is going to be 9 divided by 2.88 squared, which is 1.09. All right, so those are the dimensions we're looking for. All right, the radius should be 2.88 inches, and the height should be 1.09 inches. All right, so hopefully that fixes the issue that we were having in class.